Okay, there's another way of solving systems of equations that I think is pretty cool called Cramer's rule. And so this right here is our rule that we have, that if I have a system of equations that where I have a number x plus a number y equals c, a number x plus a number y equals a number c, that I can set it up as some determinants based on what my numbers are here. And if I work that out, then it will give me what x equals and what y equals. So there's a pattern here that is pretty easy to remember and is pretty cool, if you ask me. And so I'm going to try to get this to be a highlighter, not a pen, which I thought I'd already done. Hey, there we go. But that's a little too wide. Okay, so if I look at what my A's are here and where they are in my actual matrix, not matrix, well, like in my determinants, I have them in these three places. If I look at my B's, then I have B's here, here, and here. And then if I look at my C's, I have here and here. And so here's my pattern, is on the bottom, my matrices are the same, and they are made up of my A's and my B's. On the top, I use the same matrix, except whatever I'm solving for, I replace with a C column. So I'm solving for X, which means in the X column, I put my C's. Then my Y column stays B's. When I'm solving for Y, my A column stays A's. My Y column switches to C's. And this just means, like, if it works out that my determinant equals 0, then this doesn't actually work out. The determinant that's on the bottom, like I can't divide by 0, is all that's saying. So let's look at an example of this. So let me make sure that I got there we go. All right, use Cramer's rule to solve the system 4x plus y equals -7, 6x plus 2y equals -8. We're going to use Cramer's rule. Again, this is one of those situations where, yes, it's easier to just, say use elimination or substitution on this, but if we had a much more difficult problem with many more variables, this would be an easier thing to do, assuming we had a calculator to do the determinants for us if it was really long. So basically, I have an x equals a fraction. We're going to have a determinant on the top and the bottom. And then I have a y equals a fraction with a determinant on top and a determinant on bottom. And I just need to figure out what to put in each of those places. So my A column here, 4 and 6, goes on the bottom in the X column, or the first column, and it goes on my Y's. Okay, the only place that my X's don't go are in the X column when I'm solving for X. Now let's look at our Y columns. This would be the 1Y, so I'm talking about 1, 2. My B columns go everywhere in the second column except for where I'm solving for y. And then the C column just finishes off whatever I have left. So this is -7, -8, -7, -8. Now I need to find some determinants. So remember, this is the diagonal, -7 times 2 minus the other diagonal, -8 times 1. Okay, so -14. There's two negatives here, which is going to make this +8 equals -6. That's an 8. Okay, so that gives us a -6 on top. On the bottom, I would do 4 times 2, minus 6 times 1. That's 8 minus 6, which is 2. So negative 6 over 2 is negative 3. That is my x value. On the second one, keep in mind that my bottom two matrices are the same, so I already know this is over 2. On top, I do 4 times negative 8 minus 6 times negative 7. That's negative 32 plus 42. I have two negatives which make it positive, and that gives me 10. So I put that 10 on top. That means y equals 5. So my answer is negative 3 comma 5. Not too bad, eh? That's for a 3 by 3. Let's look at a, okay, not a 3 by 3. That's for a 2 by 2. 2 variables, 2 equations. Let's look at a 3 by 3. 3 variables, 3 equations. Okay, so let's look at this highlighted again. My A's are everywhere in the first column except for when I'm solving for x. Okay, everywhere in the first column except where I'm solving for x. My B's are in the middle column everywhere except for when I'm solving for y. My C's are in the third column on every one of them except for when I'm solving for z. And then my D's, oh, I forgot to highlight that. My D's fill in what's left. When I'm solving for x, the D column's in the first column. When I'm solving for y, it's in the middle column. When I'm solving for z, it's in the third column. Okay, so now let's solve this. Now this is where if we have to do all of these determinants by hand, that's going to be pretty annoying. So we're going to do these with the calculator. Okay, so I'm going to set this up, and I'm going to put a matrix on top, and then I'm not going to put the matrix on bottom, because what we're going to do is we're going to work this matrix out for the bottom one time, and put it on the bottom of each of our fractions. This, you know, lopsided thing. This right here, where I have my x, y's, and z's, is the bottom of each one of our determinants. Okay, so I'm just going to calculate it once and then put it on the bottom of each. All right, so to do that, I'm going to bring up my calculator. And this is what we did in the last video I made. So second, x to the negative 1. I'm going to go over and edit matrix A. And I still have a 3 by 3. So I just need to change this to the numbers I have. Remember to make sure that you put in everything right. Okay, and this is a video, so if I go faster than what you can do yourself as you're following along, you can always pause and catch up and then start it going again. So I'm going to exit this by doing second mode, and the last thing I did on my calculator was the determinant of A, so I could just press enter. And this is really the determinant of the new A. But if that's not the last thing you did, then you'd go to second, x to negative 1, you'd go over to math, and have determinant highlighted like it is, so press enter, and then second, x to negative 1 for matrix, and then press enter to put the A in. Okay, that is 58. How in the world did that just end up being a highlighter? Oh well. So 58 goes on the bottom of each of these fractions. Now I just need to figure out the top part. Okay, so my x's go in the first column in all of them but x. So 3, 2, 1, 3, 2, 1. Okay, my y's go in all of them but when I'm solving for y. Negative 2, 3, 4. I'm solving for y, so it doesn't go in this one. And then negative 2, 3, 4. For my z's, it goes in all of them but the one where I'm solving for z. And then my last column, which I don't really have a new color for, goes where I have left. So in the X, when I'm solving for X, it goes in the X column. When I'm solving for Y, it goes in the Y column. When I'm solving for Z, oh, I messed up. I shouldn't have put that there. Oh, that's close enough. In the Z column, it goes where I'm solving for, it goes where I'm solving for Z in the Z column. Now, again, this would be a lot of matrices to do by hand, so let's do it on the calculator. So, second matrix, edit, A, still 3 by 3, 16, then the negative 2 is right, the 1 is right, and then negative 9, then the 3 is right, the negative 1 is right, then 2, then the 4 is right, and the 3 is right. So I'm going to quit. And remember, I just did the determinant of A. That's where my new matrix is. So if I press enter and get 116, then that means that this is 116 over 58, which equals 2. So x equals 2. Then I'm going to go and put in my next one. Second matrix. Edit. Still a 3 by 3, so 3, then 16, then 1, 2, negative 9, negative 1, 1, 2, 3, and then I can just press enter. That should be negative 174 over 58, which is negative 3. And then the last one, second matrix edit, I get 3, negative 2, 16, 2, 3, negative 9, 1, 4, 2. Second mode to quit and press enter, you get 232 over 58, which is 4. Yeah, 4. So my x is 2, my y is negative 3, my z is 4. So that is my answer. See how much less room that was than when we did it by matrices or when we did it by elimination. So this is a pretty cool way to solve systems of 3 equations using Cramer's rule and determinants.